Today we're doing section 5.5, day 4, and we are going to be using some identities in order to solve the equations for today. So for our first example, we have 2 cosine squared of x plus 3 sine of x. And this is equal to 0, and they want the solutions within the interval of 0 to 2 pi. So remember, after all is said and done and we set up our equations, we need to get our answers that fall between 0 and 2 pi. So the first thing that you should notice when we're looking at this problem is that I have a cosine and I have a sine. So I can't isolate one of these trig functions by themselves because I have 2 different trig functions. But I know that I have an identity that would let me replace cosine squared of x. So I'm going to replace cosine squared of x with 1 minus sine squared. So this is going back to our Pythagorean identities, and if I manipulated sine squared plus cosine squared equals 1, I can replace that with that. So notice by doing that, now I have all the same trig function, and now it kind of goes back to a problem like yesterday. So I'm going to distribute this in. So I'll get 2 minus 2 sine squared of x plus 3 sine of x is equal to 0. And now I need to reorder this so that all my terms are in the correct order. So I have negative 2 sine squared plus 3 sine plus 2. And typically we never deal with our a value being negative. So if I want to get rid of that a value of a negative 1, I can simply divide all of these terms by a negative 1 so that it works out a little bit better. So by doing this, it'll clean it up, and I'll have a positive 2 sine squared of x minus 3 sine of x minus 2. And 0 divided by negative 1 is still 0. So essentially, I just changed all my signs. So I'm going to switch to this next screen so I have more room to finish this problem. So that was a 2 sine squared minus 3 sine of x minus 2. And we have to factor this. So remember, in order to factor, we multiply a times c. So I'm dealing with a negative 4 sine squared. And I need to figure out what multiplies to be negative 4 sine squared and what would add to be a negative 3 sine. So the combination that we're going to use is a negative 4 sine and a positive sine. So once we figure out our combination, we go back to the problem. I'm going to split it up. I have 2 sine squared of x minus 4 sine of x plus sine of x minus 2. No, the order does not matter. These could be reversed and you would still get the same answer. And now we group our first 2 terms, and I group my second 2 terms. My boxers, these would be your 4 terms that go in the box. Now I figure out what I can pull out, so I would take out a 2 sine of x, because that's the GCF, and I'd be left with sine of x minus 2. My second quantity, I can take out a positive 1, so I'm left with sine of x minus 2. And now notice they have these 2 binomials in common, so that's kind of like our new GCF, and I'm taking that out of both of them. And now I'm left with 2 sine of x plus 1. And that's coming from the leftovers right here. And now I need to set both quantities equal to 0. So for this first binomial, I'll get sine of x is equal to 2. And for my second quantity, I'll get sine of x is equal to negative 1/2. And the last thing we have to do here is figure out what our angles are going to be. So for this first quantity, for this first one over here on the left side, no trig function, no angle would ever give me a value of 2 in the y spot. So for this, I don't get a solution. However, over here, I know that 1/2 is going to be in the y part of the denominator when the coordinate is a 6. And I know sine is negative in quadrants 3 and 4. So my answers would be 5 pi over 6 and 7 pi over 6. I was just kidding. This one should not be 5 pi over 6. This one should be 11 pi over 6 coming from our quadrant 4. And some of you were asking in class if you had to set it up. So let me just go to the next screen real quick. So if I set it up as 7 pi over 6 plus 2n pi and 11 pi over 6 plus 2n pi. So when n equals 0, I would get the two answers of 7 pi over 6 and 11 pi over 6. The moment I plug in 1, if you look at this, the moment I plug in 1, I would get 2 pi. So anytime I add 2 pi to another angle, I'm going to be bigger than 2 pi, and I know that the cutoff is 2 pi. So that's why I don't need to check n equals 1, and these are my two answers. So one more example for today. So this problem is cosine of 2x plus 3 sine of x minus 2 is equal to 0. Okay, so now we need to, again, use our identities. So notice I have two trig functions. I have a cosine and a sine. So one of them I can use a formula for, and that's the double angle, which is right here, cosine of 2x. And I want you to look at your formula sheet and notice that there's 3 versions to choose from. There's the cosine squared minus sine squared, 2 cosine squared minus 1, and 1 minus 2 sine squared. So the one I would want to select is the 1 minus 2 sine squared. And the reason I would want to do that is so that I'm getting all my trig functions to be the same. So now I need to clean this up a little bit. This 1 and negative 2 can be combined. So I have negative 2 sine squared of x plus 3 sine of x minus 1. Again, I'm going to divide by a negative 1 to kind of change all these signs so my a value is not negative. So I have a positive 2 sine squared minus 3 sine of x and a plus 1. So now I need to multiply a times c. So my a times c would be 2 sine squared of x. And the combination that multiplies to be 2 sine squared of x and adds to be negative 3 would be a negative 2 sine of x and a negative sine of x. So I'm going to flip this to the screen, and I'm going to do this one the box method. So if you don't do the box method, don't do it this way. Do it the way you normally do it. So for my boxers, you're going to put a 2 sine squared. I put the negative 1 here, and then I have a negative 2 sine of x and a negative sine of x. And now I have to find the outside. So going from the top row, they have a 2 sine of x in common. Going up and down, they have a sine of x in common. Over here, they have a negative 1 in common. And over here, they have a negative 1 in common. And I actually copied this wrong. This should be a positive 1. So this breaks down to be 2 sine of x minus 1 and sine of x minus 1. So my groupers, you should have still got this as your final answer after you factored. So now we need to set them equal to 0 and solve. So for this one on the left, I get sine of x is equal to 1/2. And this one I get sine of x is equal to 1. And now I need to solve. So for this first one, when the y value is 1/2, that means it's coming from a pi over 6. And I know sine is positive in quadrants 1 and 2. So x is going to equal pi over 6 and 5 pi over 6. And from my second statement, I know that when sine is 1, when the y value is 1, the coordinate is a pi over 2. So these are our 3 answers for the problem. So that's all for today.